Alright, here's the last video of a series of 3 where we're looking at the formation of molecular or covalent compounds. We're going to look at here the formation of methane. So let's start on the left hand side. It says carbon has 4 valence electrons and a core charge of +4. It has room for 4 electrons. So when we look at carbon here, it's in group 4A. So that, again, the group number is going to tell you the number of valence electrons and the core charge. And so this is why we noted that carbon has 4 valence electrons and a core charge of 4. In the diagram you can see that 1, 2, 3, 4 valence electrons, each at top, bottom, left, right, like we learned in class. And then there's his core charge there, +4. Hydrogen has 1 valence electron and a core charge of +1. Again, hydrogen is in group 1A, so that's where we get that information. When you look closely at each of the hydrogens here, you'll notice +1 core and a 1 valence electron. Now, the question is, why are there 4 hydrogens here and 1 carbon atom? Well, when you look closely, you'll notice that carbon has 4 valence electrons and needs 4 more to get a full valence shell. So if it tries to steal 1 electron from each of these hydrogens, it will get to 8. So we actually need 4 hydrogen atoms in order to satisfy the both hydrogen and carbon in terms of filling their valence shell. So let's jump to the next column. It says hydrogen's electron is strongly attracted to carbon's core, and that applies to all of those hydrogens. Carbon is more electronegative because of its larger core charge. So again, carbon is way over here. It has a +4 core charge. Hydrogen's over here. It has a +1 core charge. So that's going to make carbon better at stealing electrons and holding its own. Now, of course, like we noted in the previous video, hydrogen is also smaller. And so that helps to compensate for a little bit for its smaller core charge. So hydrogen is pretty electronegative because of its smaller size. And so there's going to be this tug of war for electrons. But you can see here, because carbon has a higher core charge of +4, it's more electronegative, it's going to be pulling on these electrons here, and that's what's shown by the arrows. Hydrogen, again, though, fights back. Because it has some electronegativity, it has some strength, and so instead of the electron being completely stolen, what happens instead is hydrogen's valence shell gets stretched out towards the carbon. Again, hydrogen's trying to fight back. It's trying to hold on to its own electron. So it says here hydrogen fights back. It still attracts its own electron to its core. Again, notice the valence shells are overlapping, and that's where electrons are starting to be fought over. Eventually, like we saw in the previous examples, there's a resolution to that. Carbon and hydrogen say, okay, let's just share the electron, and we're both happy that way. And so when you look at this diagram here, again, hydrogen's valence shell is overlapping carbon here and in each of these other 3 positions. Where the valence shells are overlapping is where you have 2 electrons. And those 2 electrons are being shared by both atoms. They spend time around both atoms, and we call that the covalent bond. So that's why it states right here the atoms share their electrons in covalent bonds. There's a covalent bond here, 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 and here. And notice, again, hydrogen has 2 electrons. Its valence shell is full because that first shell, remember, only requires 2 to be full. Carbon has 8 electrons around it, so its valence shell is full. Both atoms are happy by sharing their electrons. And so now these atoms in this configuration or in this molecule is stable, more stable compared to what they were as individual atoms over here. Okay, take care.